Good afternoon and welcome to Hand Wavy Chemistry. Today it's problem time where we answer chemistry questions. The topic for today's questions is redox reactions. Redox is an abbreviation for the term reduction oxidation, and it refers to chemical reactions where an electron is transferred from one atom to another. Redox is an abbreviation for the term reduction oxidation, and it describes reactions where at least one electron is transferred from one atom to another. The atom that gains the electron is said to be reduced and its oxidation number decreases. The atom that loses the electron is said to have been oxidized and its oxidation number increases. In order to balance a redox reaction, chemists will usually split it into two separate reactions, known as either half equations or half reactions, balance each one of these on their own, and then recombine it. We're going to work through 4 different problems today. The first will seem relatively trivial and could be solved without using half equations. The second will be a bit more complex and help to show why half equations are so useful. And the final 2 questions we will deal with reactions happening under either acidic or basic conditions.
This is our first trivial example, and although we can balance this without having to use half equations, it will at least let me demonstrate what I mean by them. But first, let's balance it the normal way. On the left-hand side, we can see that we have one sodium atom and 2 chlorine atoms reacting to give sodium chloride. So we have 2 chlorines on the left, but only 1 on the right. So we're going to put a 2 out front. Now we have the same number of chlorines on each side. However, we have 2 sodium atoms on the right, but only 1 on the left. So we're going to need to put a 2 out the front here as well. Now everything is balanced. But let's do the question again using half equations. So rather than making sodium chloride, we're going to make Na plus and Cl minus. So we're going to separate out into 2 separate equations. We have sodium reacting to produce Na plus. We have the same number of each type of atom on either side. However, there is no charge on the left, but there is a positive charge on the right. To balance this out, we need to add in 1 electron. For the second line, we had Cl2 going to form Cl minus. So we have 2 chlorine on the left, but only 1 on the right. So we'll put a 2 out the front. Now again, we look at the charges. We have 2 negative charges on the right, but no charge on the left. So we will put in 2 electrons. At this point, each of these half reactions is balanced, but they don't have the same number of electrons. So we need to fix this before we can combine them. The bottom equation has 2 electrons, the top one just has 1. So we're going to take all of this and multiply it by 2. So this would give us 2 sodium reacting to give 2 sodium ions and 2 electrons. At this point, we can add the 2 half reactions together. We get 2 Na plus Cl2 plus 2 electrons reacting to give 2 Na plus 2 Cl minus and 2 electrons. We can cancel out our electrons because they're on both sides. And we have our final answer, which is exactly the same as what we have up above. The 2 sodium atoms react with 1 chlorine molecule to produce 2 sodium chloride molecules. Our second question is similar to the first, but just a little bit more complicated because nothing just balances straight off the bat. So we'll start by separating into 2 half reactions. We'll start out with our triiodide ion going to form I-. There are 3 iodine on the left-hand side, but only 1 on the right. So we'll put a 3 out the front. Now we have the same number of atoms on each side. We need to look at the charges. The triiodide ion has a charge of -1, and each iodide on the right-hand side has a charge of -1. So we have -1 on the left and -3 on the right. So to make the charges balance, we're going to need to add 2 electrons to the left-hand side. Now this is balanced. We'll look at the other half of the reaction. We have our S2O3 2- reacting to produce S4O6 2-. On the left, we can see we have 2 sulfurs, 3 oxygens. On the right, 4 sulfur, 6 oxygen. So we'll put a 2 out the front on the left-hand side. Now we have 4 sulfur and 6 oxygen. So that balances, but our charges don't. We have a -4 charge on the left and only a -2 on the right. So we have to add 2 electrons. This time, each of our half reactions involve the same number of electrons. They each have 2 electrons, so we can just add them together as they are. And we'll get that we have triiodide plus 2 S2O3 2- plus 2 electrons react to form 3 I- plus S4O6 plus 2 electrons. And then we can cancel out the electrons on each side, giving us the final equation. The reason I actually write out and then cancel the electrons is because this gives us a way to double check we haven't made a mistake. Rather than just assuming they're going to cancel and ignoring them when I add together, explicitly writing them and double checking reduces the risk of us making a silly preventable error. For this question, we're working under acidic aqueous conditions. So the strategy we're going to use is we'll start by balancing the non-oxygen, non-hydrogen atoms. Then we can add water to balance out any oxygen we need. Then we can add H+ to balance out any hydrogen we need. And finally, we will add electrons to balance out the charge. Something else that makes this question quite interesting is that we only have one material on the left-hand side. So our 2 half equations are both going to involve S2O3 2-. So let's write out our first one. S2O3 2- is going to react to produce sulfur. We can see we have 2 sulfurs on the left-hand side, 1 on the right. So this is quickly fixed with a little 2 out front. Our sulfur is balanced. Now we look and we see that we have 3 oxygen on the left-hand side, none on the right. So we will add 3 water molecules, balancing the oxygen. But now we have 6 hydrogen on the right-hand side, none on the left. We're in acidic conditions, so we can add 6H+. Finally, we need to look at our charge. On the right-hand side, it's neutral. There's no charge. But on the left-hand side, we have a -2 and 6+, so that's a total of 4+. So to get it back to neutral, we need to add 4 electrons. This equation is now balanced. Now for our other half equation. Again, it's S2O3 2-, but this time it's reacting to give us SO2. Once again, we have 2 sulfurs on the left-hand side, but only 1 on the right. So we'll put a 2 out front. Now we have 4 oxygen on the right, but only 3 on the left. So we need to add water. 2 hydrogen on the left, so we have to add 2H+. Now we think about charge. -2 on the left-hand side, +2 on the right-hand side. We're going to need 4 electrons on the right-hand side to make everything balance. Now, because both half equations have the same number of electrons, we can add them together, which gives us 2s2O32- plus 6H plus an H2O and 4 electrons reacting to produce 2 sulfurs plus 3 waters plus 2 sulfur dioxide plus 2H plus and 4 electrons. Now there's a whole lot of simplifying that we can do now. The 4 electrons and the 4 electrons, they cancel. We have 2 hydrogen on the right, 6 on the left, so we can get rid of the ones on the right and update the one on the left to be 4H plus. We have 1 H2O on the left, 3 on the right. We get rid of this one and update this to be A2. That's everything that cancels out. But if we look through, we can see that we have 2 S2O32-, 4H plus. We have 2 sulfur, we have 2 water, and 2 SO2. Everything is a multiple of 2. So we can divide the entire equation by 2, giving us the simplified answer that S2O32- plus 2H plus react to produce S plus SO2 plus H2O. And now everything is balanced and we have our answer. Now for our final question, we're going to balance a reaction under basic conditions. The easiest way to do this is to first balance it under acidic conditions and then convert them to being basic. Let me show you what I mean. Our first half reaction is going to be the MnO4- going to produce MnO2. We can see that the amount of manganese on each side is already balanced. All we have to do is account for the missing oxygens on the right-hand side. So we'll do that by adding in 2 water molecules. Now that we have our water molecules, we need to add protons to balance out the hydrogen. There are 4 hydrogen on the right-hand side, so we need 4 protons on the left-hand side. With all the atoms accounted for, it's time to think about charge. The right-hand side, neutral, no charge. Left-hand side, sums to +3, so we're going to need 3 electrons. And now everything is balanced. So let's look at the other half equation. SO32- reacting to produce SO4-. The sulfur is already balanced, but we are missing an oxygen on the left, so we'll add water. Now our oxygens are balanced, it's time to add H+, so we'll put 2H+ on the right-hand side. All the atoms are accounted for, now to balance charge. The left-hand side is at -2, the right-hand side is neutral, so it's going to need 2 electrons. Looking at our 2 half equations, we don't have the same number of electrons for each line. So we'll account for this by multiplying our top equation by 2 and our lower equation by 3. This should give us 6 electrons for each half equation. So now let's add them together. We'll get 2 MnO4- plus 8H plus 6 electrons plus 3 SO32- plus 3 H2O reacting to give us 2 MnO2 plus 4 water plus 3 SO42- plus 6H plus 6 electrons. Good news, we have the same number of electrons on both sides, so those can cancel. We have 6H+ on the right, 8 on the left, so we get rid of those 6 and chop this down to 2. We have 3 water molecules on the left, but 4 on the right. So we can get rid of these 3 and update this to being just 1. Everything is now balanced. However, the question said that we were in basic conditions, so we can't have H plus as one of our reactants. The way to account for this is we add OH minus to both sides to convert those H pluses into H2O. So we have 2H plus, so we're going to need to add in 2OH minus, and we'll need to do the same to this side as well, 2OH minus. Now let's rewrite our equation. 2MnO4 minus plus 2H2O, the H plus and the OH minus combine to make water, plus 3SO3 2 minus react to produce 2MnO2 plus a water plus 3SO4 2 minus plus 2OH minus. We have a water on the right hand side, 2 on the left, so we can cancel and cancel, giving us our final answer.
I hope you have enjoyed this video, and if you have, please make sure to like, subscribe, and share it with your friends. And if there is a question you'd like to see answered in a future problem time, please put it down in the comment section below. Thank you, and I hope you have a wonderful rest of your day.